Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever feel like when you are trying to do research, especially in psychology, you get stuck on the data and don't even get to the fun part of understanding the results? Well, this new study dives into exactly that. This paper explores how psychology students handle data. Specifically, it looks at the difference between working with data that is already cleaned up and data that is still messy, raw, and needs a lot of work before you can even start analyzing it. They found that even though students learn a lot about statistics, actually preparing the data can be a huge roadblock. Imagine this: you've taken all your research methods classes, you've learned all about different statistical tests, and you feel ready to tackle your dissertation or a big project. But then you open up the raw data files, and they look nothing like the neat, tidy data sets your professors used. This is a really common experience for psychology students. Most courses focus on the decision tree of statistical tests, but they don't spend enough time teaching you how to clean and prepare the raw data. This is a crucial skill, not just for academic research, but for getting a job too. In fact, data processing was the second most frequent skill used by psychology graduates in their jobs. So, the big question this study wanted to answer was, can psychology students actually tidy up raw data, and what kind of struggles do they face when they try? To figure this out, the researchers designed a cool experiment. They got psychology students to do a data analysis task. Some students were given data that was already processed and needed very little work. Others got unprocessed data that required a bunch of steps to clean and organize before they could even start the actual analysis. Both groups had to answer the same research question using the data. After they finished, the researchers collected information on what results the students got and how they felt about the whole process. The task involved analyzing data from a simulated Simon task. This is a common psychology experiment where people respond to colors. The data had information about how fast people responded and whether they were doing the task with or without a distraction like music. The students had to calculate things like average response times. Figure out the Simon effect, which is the difference in reaction times between when the color and response match versus when they don't, and then run a statistical test to see if the distraction made a difference. This diagram shows you what we mean by processed versus unprocessed data. For the processed data, it is pretty straightforward. You import it, maybe do a couple of quick calculations, and you are pretty much ready to go. But for the unprocessed data, you have to do a lot more. You have to join two different files together, work with data that is in a long format, and then restructure it. These are all steps that can trip you up if you haven't been taught them properly. Now, let's look at what they found. When it came to actually getting the correct result, 92% of students who used the processed data got it right. That is pretty good. But for the students who had to wrangle the unprocessed data, only 76% were successful. That might still sound okay, but the researchers also noticed that a lot more students in the unprocessed group dropped out of the study altogether. This graph shows the attrition rates. You can see that a much smaller percentage of students in the unprocessed group made it all the way through the study compared to those who had the processed data. This tells us that the data wrangling part was a significant hurdle for many students. Beyond just whether they got the right answer, the researchers also asked students about their experiences. What resources did they use? Well, Google was a big one, along with textbooks and things like generative AI. It is interesting to see that students are leaning on these tools to help them navigate the data. Looking at the qualitative data, one of the most common themes was how students describe data wrangling as, like solving a puzzle. Many found the problem-solving aspect rewarding. However, they also reported challenges in figuring out the right steps to take without being given very specific instructions. They liked the challenge, but they also struggled when they had to make their own decisions about how to process the data. When asked about their overall feelings, many students found the experience rewarding, even if it was tough. They felt accomplished when they solved the tricky part of the data analysis. But there were also recurring themes of lacking confidence, especially when they didn't have clear, step-by-step instructions and sometimes feeling overwhelmed. So, what does all this mean? The study clearly shows that working with unprocessed data is significantly more challenging for psychology students. The higher attrition rate and lower success rate in the unprocessed group are strong indicators of this. The qualitative findings reveal that while students enjoy the puzzle-like nature of data wrangling, they struggle when they lack prescriptive instructions. They can often follow steps, but making their own decisions about how to organize and clean data is where they hit a wall. This aligns with the idea that learning to transfer knowledge to new, unstructured situations is a key step in becoming proficient. This leads to some important implications for how psychology research methods are taught. First, the paper strongly suggests that data wrangling needs to be taught explicitly and much earlier in the curriculum before students start their independent research projects. They recommend a scaffolded approach, starting with clear instructions and then gradually giving students more freedom to practice and generalize their skills. Second, they highlight the importance of using freely accessible software like R or JASP, as students often lose access to paid software like SPSS after graduation. Using tools that support reproducible workflows is also key. Finally, they point out that teaching examples should include significant findings, as many students assume they've made a mistake when they get a null result, mirroring the publication bias in research. Now, like any study, this one has its limitations. The biggest one is selection bias. The students who volunteered for this study were likely more interested in data work than the average student. Also, the students who actually completed the study were probably the most motivated. This means the challenges faced by these participants might be just the tip of the iceberg compared to what other students experience. Furthermore, using free text reflections limited the depth of the data, and future studies could benefit from interviews or think-aloud protocols to get richer insights. In conclusion, this study provides compelling evidence that psychology students need more structured training in data wrangling. The ability to prepare data is just as important as knowing statistical tests, and it is a vital skill for both academic research and future careers. By embedding these skills, providing accessible tools, and using diverse examples, educators can better equip students for the real world of data analysis. My take on this is that it is a really important study highlighting a gap in many psychology programs. We focus so much on the theoretical what of statistics, but the practical how of getting the data ready often gets overlooked. The like solving a puzzle analogy is perfect because it captures that initial satisfaction students get, but also the frustration when they don't have the right tools or knowledge to solve it. It makes sense that students would struggle without prescriptive instructions. It is like being given a recipe with missing steps. Future research could explore more deeply why students struggle with this transition from guided to unguided tasks, and perhaps look at specific pedagogical approaches that are most effective. I think the call for using freely accessible software is also crucial for equity and employability. What do you all think about the way research methods are taught? Let me know in the comments below. If you found this breakdown helpful, please give it a thumbs up, subscribe to Rubin's Mind Lab for more science explained simply, and hit that notification bell so you don't miss our next video. Thanks for watching, and I'll see you in the next one.